All right, so we're going to do an example of a quadratic function. This one is in factored form. Okay, so the main advantage of something that's in factored form is that it makes its roots, or it makes its x-intercepts super easy to figure out. So first off, let's go ahead and do the what direction it's opening. So because my a value here is negative, that's the reason that I know it's going to be opening down. Okay, we'll do the y-intercept. All right, for the y-intercept, we're just going to plug in 0 for these x's. So it's going to be negative 2. We'll do 0 minus 5, so negative 5. 0 plus 3. And then we'll just work this out. This will be 10. 10 times 3 is 30. That's our y-intercept. And then this right here, this is going to be our key information this time, the x-intercepts. All right, it's super easy to find. We'll plug in 0 for y, I guess. But we can already tell just by looking at the original function what the x-intercepts are here. So because it's in factored form, we can automatically figure out what x has to be. Okay? If x minus 5 is a factor, like it is here, that means that x equals 5 is a root, or it's a solution, or an x-intercept. If x plus 3 is a factor, that means that negative 3 is a solution. So all you do is you take those factors, x minus 5, and you set it equal to 0. When you solve this, you're going to get x equals 5. Okay. When you solve x plus 3 equals 0, you'll get negative 3. But these guys right here, that's going to tell us, this piece and that piece, that's going to give us a pretty good idea for what the graph of this function is going to look like. Okay, I'll scroll up so I can do this. If I were trying to get an idea for what the graph looks like, I would just plot these intercepts. All right, 5 is an intercept, so that means it's going to cross the x-axis there. Negative 3 is an x-intercept. All right, so I know it crosses here, and I know that it's opening down. So because it's opening down, all right, I know it's got to be having some shape like this. All right, that information alone gives me a rough idea for what the graph's going to look like. All right, I would just draw something like this, and that's basically what the graph's going to look like. I don't have exactly what the vertex is yet, and I didn't label what the y-intercept was, even though I know it's 30. But just knowing the roots and whether it opens up or down, that should give you, most of the time, that should give you the idea for what the graph looks like. Okay. If you have to figure out the vertex, if you're asked that for some reason, probably the way that someone would do it would be to expand this out and then work it in standard form. But we can figure out the vertex. Again, we can figure out the vertex based on these intercepts. I told you once upon a time that the vertex, it is directly in between these two intercepts. So whatever number is directly in between negative 3 and 5, that's going to be the x value of the vertex. So to figure out the x value, what I'm going to do is I'm going to add these two up and then divide by 2. So I'll do 5 plus negative 3 divided by 2, and that's going to tell me the midpoint. That's equal to 1. And then, the idea is that if you have your x value, you can figure out the y value by just plugging in your x value. Okay. So to find the y, I'll do negative 2, and I'll do 1 minus 5. Then I'll do 1 plus 3, which is 4. And then work this out. That'll give me my y value. This is positive 8. 8 times 4 is 32. So my vertex is the point 1, comma 32. Nice. All right, so 1 and then 32 high, that's going to be my vertex right there. Okay. I guess we did need to know the vertex in order to figure out the range, right? We can't have the range without knowing that vertex. So since it's opening down, I know that the lowest it goes is negative infinity. And then the highest it goes is going to be that y value there, 32. And it actually passes through 32. Or in algebraic form, it would be less than or equal to 32. All right, a lot of information, right? But the bulk of it is just knowing what the intercepts are. That's 9 times out of 10. That's the kind of stuff that they'll ask you is, what's the x-intercept if they're giving you something in vertex form or factored form. Now, if you want to figure this stuff out with your graphing calculator, I'll do that here. I'm going to do -2, parentheses x minus 5, x plus 3, and then we'll graph it. So zoom standard. So you see here we're missing a ton of the information because the calculator's lopping off all the top part. So what I'm going to do is I'm going to extend my y values. I'm going to change my window so that my y maximum is higher. So the window, I'm going to change my y maximum to like a 40 and then press graph. There we go. All right, and then you could go through all the stuff to figure out, use your trace to figure out that your y-intercept is 30. You just plug in 0 for x. You could scroll down here and try to make a guess for what your intercepts are. Looks like -3. Of course, if you plug in 5, you'll get that one. And if you try to figure out the peak, okay, it looks like the highest it goes right here is 32, and it looks like that's happening at 1. And then you could verify it just by plugging in 1 for x. All right, that's it for the factored form.